Hello 3D printing friends. Today on the BV3D channel we'll take a look at this very impressive 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. This episode of the BV3D channel is brought to you in part by these awesome channel members. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're getting a first look at this absolute speed demon of a printer, the X1-Carbon from Bambu Lab. Big thanks to the team at Bambu Lab for sending this over. Right off the bat, I'm going to tell you that this is about to launch as a Kickstarter campaign. Although by the time this video is out, it will probably already have launched. It's important to remember that Kickstarter is not a store, and it's not a pre-order system. It's a crowdfunding platform where a company or an individual launches a campaign asking people to pledge money to help bring their product to market. They offer rewards as an incentive for pledges at certain dollar amounts. These rewards are often in the form of the finished product at a significant discount from whatever that product's retail price was supposed to be. In other words, there might be a product that's expected to sell for $200 at retail, and by pledging your support of $100, the company or individual pinky promises to send you the product when it's ready. So, if and when the product reaches its funding goal, Kickstarter cashes in all those pledges and transfers the funds, minus their cut, to the aforementioned company or individual. At that point, Kickstarter has done their job and the rest is up to that company or individual responsible for the campaign. If the campaign goes off the rails and the product never ships, well, you're out the money. That was the risk associated with the reward. So I always remind people that when it comes to Kickstarters, don't pledge more than you're willing to throw away. And if the Kickstarter aspect of it is off-putting, well, wait it out until after the campaign is done. The actual retail price is still way more than reasonable for the feature set, and we'll get to that feature set in just a sec. So I've been largely staying away from Kickstarters unless there's something really compelling about them. And there's some really exciting stuff about the Bambu Lab X1-Carbon. For instance, it uses force sensors in the bed for auto leveling and a micro LiDAR scanner to handle linear advanced calibration, flow rate calibration, even scanning the bed before and after the first layer of your print to make sure it's giving you the best possible result. It also does a vibration calibration / sensing thing to compensate for vibration and cut down on ringing. All that means that you, yourself, don't have to turn a knob or adjust an offset or meticulously tweak the bed in order to get a good first layer. It just happens. Also, it's not a kit. It arrives fully assembled. The AMS unit ships inside the print chamber in a carrier secured in place with a couple of screws. The most you have to do is remove the AMS from inside the printer and plug it in. It's like an anti-kit. You don't put the screws in, you take the screws out. And you know, this is not a pre-production unit. It's a production model. So the hardware is complete. But the firmware and the software are still under active development. So any screenshots or video of the slicer or stuff on the printer screen may be different in the final product. Other important printer specs. The build volume is 256 by 256 by 256 millimeters. The vintage 8-bit computer nerd in me gets nostalgic about 256, since that's the maximum number of values you can store in an 8-bit number. It has a heated magnetic bed with a spring steel flex plate, and there are two distinctly different print surfaces on that flex plate. One side is labeled the cool plate, and it's for PLA, PETG, ABS, and ASA. The other side is labeled the engineering plate, and it's for PA or nylon, TPU, and polycarbonate. And the bed can get up to 120 degrees Celsius. The proprietary all-metal hot end with a hardened nozzle can get up to 300 degrees Celsius. The chamber is passively heated by the bed, and it can get up to 60 degrees Celsius. But even though it's passively heated, the temperature in the chamber is managed, and there's an exhaust fan to vent the air if it's getting hotter than needed. In addition to the parts cooling fan on the tool head, there's also a big auxiliary blower on the left side of the printer to help cool the print, and that's important for printing fast. Speaking of printing fast, the printer has a CoreXY motion system, a welded metal frame, 20 meters per second squared acceleration. That's 20,000 millimeters per second squared. And it can move the tool head around at up to 500 millimeters per second. It is insanely fast. It can blast out a really good Benchy in like 18 minutes. Although to be fair, that's a custom-tuned G-code file from Bambu Lab, and they know their slicer and printer better than anyone. I can use the standard 0.2mm layer settings in the slicer with no changes and get an amazing 30-minute Benchy. Now, with great speed comes great decibels. When this printer's idle, you barely know it's there. But when it's going full blast, you can definitely hear it. In addition to being faster than any other printer I've ever used in my life, the X1-Carbon has an onboard camera that can be used for remotely monitoring a print job. And it's got a premium, polished, high-end look and feel. Okay, so although the Bambu Lab X1-Carbon's hardware is complete, again, this is a production unit, there's still stuff under development. As of right now, the ability to record a time-lapse from the built-in camera is still under development. The ability to detect a failed print, otherwise known as a failing spaghetti monster, is also under development. The Android and iOS apps are still being worked on, and the slicer is still being developed. But despite all of the still being worked on stuff, the basic usability is there. So let's talk about the app. The Android and iOS mobile apps are coming along pretty well. I'm an iOS user, so I can only show you that one. It's got 4 main pages: Home, Shop, Devices, and Me. At this point, the home page is still under construction. Wow, doesn't that sound like a phrase from the 1990s? Anyway, it's got a selection of recommended items. Yes, this is looking similar to other model browsing sites, and I'm hoping this one won't be like a certain other cloud service I recently made a video about. Right now, the shop page is very similar to the home page. I'm not certain whether they're going to allow creators to sell models there, I mean it does say shop, or if this is all just going to be free models. Again, this is all still under construction, so this could change. The devices page is where your Bambu Lab printer is shown. This is the part of the app that's the most fully developed, and arguably it's the most important. From here, you can control the printer and monitor an in-progress print. You can see the temperature of the nozzle, bed, and chamber. You can control the part cooling and aux cooling fans. You can home the axes and move them around. And although not ready yet, it looks like you'll be able to control the AMS from here. There's a tab at the top for time lapses, but that, along with the Videos tab, are both still under construction. Finally, there's the Me page, which shows your Bambu Lab account. And a thing of interest here, at least to me, is the My History item, where you can see past prints that you sent from the slicer to the printer and whether they finished or failed. Speaking of the slicer, it's called Bambu Studio. It's a proprietary slicer that is very, very tuned for this printer. To me, it feels like it's based on Prusa Slicer, just kind of has that vibe to it in the way it does things. Its default file format is .3mf, so if you have a big project to print, you can keep multiple plates of parts and the required settings for those plates all together in one place. You can see recent projects in the Home tab, create new ones, or open other ones that maybe aren't as recent. You can slice and upload to the printer via the internet, or you can export a file to put on a microSD card. The printer has a card slot in the side of the screen, and you can print directly from the card if you want to. Bambu Studio also lets you monitor the status of the printer as well as control it and watch the printer's built-in camera. I will say I've had a persistent issue with camera monitoring which prevents me from seeing the live image. Instead, I either get a still image or it's just black, but camera monitoring works as expected in the mobile app. The slicer is still under development, so I'm expecting that issue will eventually be resolved. The list of materials in Bambu Studio is not substantial, but it's adequate. There's a nice set of materials from Bambu: ABS, nylon, polycarbonate, PLA, a couple of support materials, and TPU. There are a couple of other brand-specific materials, PLA from CoreXY and Polylite and Polyterra PLA from Polymaker. And there's a set of generics for ABS, PETG, PLA, and TPU. If none of those fit your needs, you can edit an existing material and save it as a new one. Slicing for multi-material prints is pretty easy. You can add and remove materials and set their colors. And when you have a multi-part model loaded, you can assign materials to each part. For slicing settings, you can turn on a switch to see advanced options, or you can leave it in easy mode. You can choose from several quality settings ranging from 0.08mm extra fine through fine, optimal, draft, and 0.28mm extra draft. Wait, that last one sounds like a beer on tap for engineers. Oh, when you slice, the preview will show a breakdown of how much of each material you need in order to complete the job, along with a pretty darned accurate time estimate for the print. Right now the slicer is Windows only, but Bambu Lab tells me once they've got all the features working, they're planning to port it over to Mac OS, and that's about it for the slicer. Let's talk for a moment about the Automatic Material System, or AMS. It's a 4-spool feeder and a passive dry box with desiccant packs, and the printer will accommodate up to 4 units, so you could have a single printer with 16 spools feeding into it. Loading materials into the unit is easy. Push the loading lever toward the rear of the unit while inserting filament into the hole. When the motorized filament grabber thing grabs the filament, release the lever and the AMS takes care of the rest. It pulls the filament into the unit and spins the spool around at least once, trying to find an RFID tag. Yes, there are RFID tags on Bambu Lab branded filament spools, and they identify the material type and color. But this is just a convenience, and you're not locked into using proprietary filament. You can use any spool of filament as long as it fits in the AMS. Some spools are too wide to fit, and some may fit widthwise, but could be so tall the lid on the AMS won't close. On those, at least, you can leave the lid open if you want to use them in a multi-material print. So, how does it change materials? For automatic material changes during a print job, the tool head in the printer has a cutter built into it, located between the filament drive gears and the entrance to the hot end. So when it's time to change materials, the tool head moves to the front left corner of the printer and presses its cutting lever against the left side of the frame, cutting the filament cleanly at the input to the hot end. Then the AMS retracts the filament, rewinding the spool as it does so. Then it feeds the new material in all the way down to the tool head, and the extruder takes over and feeds it into the hot end to purge out the previous material. This purge process creates a big squiggly piece of filament. When the purge is done, the nozzle gets wiped off and the squiggle slides down this chute and out of the printer. Yes, the printer poops. So I guess that makes this the poop chute. I can't believe I just said that in a video. Anyway, you can either put a spool box back behind the printer, or you can print a container to put back there to act as a sort of a litter box. And speaking of litter boxes, over on printables.com I found a great multi-material version of the cat Gigi from the animated film Kiki's Delivery Service. I loaded all of his parts into the slicer at the same time, and it asked if I wanted to load these files as a single object with multiple parts. And yes is the correct answer for this kind of model. So I loaded white, black, and red PLA into the AMS unit, and I told the slicer which filament types and colors were loaded and where. Then I assigned the colors as appropriate. The white filament is Bambu branded with an RFID tag on the spool, but the red and the black filament are Polymaker's Polyterra PLA. So like I said earlier, those RFID tags are just a convenience, letting the AMS know what filament is in its slots. You can 100% print with non-Bambu branded filament. With a layer height of 0.2 millimeters and 3 colors, Gigi takes about 5.5 hours to print. Now remember earlier when I told you about purging colors? Some of the layers have black, white, and red on them, and there's a lot of purging going on during color swaps. Between the purge squiggles, the actually pretty small prime tower, and the supports, I think I have as much or more plastic in this bag as I do in the model. If I wanted 2 Gigi models instead of 1, I could simply duplicate the one on the plate. Why would I want to do that? Well, with 2 of the same model, the number of color swaps would remain the same, and there would be 50% less purge waste on a per model basis. And interestingly, it does not take twice as long to print 2 models. Swapping colors takes a fixed amount of time. So just like cutting down on per model purge waste, having more than one of a model on the build plate cuts down on the per model material swap time. Oh, also the Bambu Lab team is planning to implement a purge to infill feature, so some of the purging can be used as infill, further cutting down on waste. Traditional single material prints are where the speed of this beast really shine. Behold the 30-minute Benchy. 30 minutes instead of an hour and a half on something like an Ender 3, and at quality. Like literally everything I print finishes 3 or 4 times faster on this printer. MacGyver's articulated dragon? Something like 5 hours. This huge Flexi Factory Imperial Dragon? Just under 8 hours. These are like all-day prints. These are like day-long prints on regular printers. The small size neutron tube from ClockSpring, about 4 hours. Remember, this is the one that would take 18 hours with standard settings on an Ender 3, and I could speed it up to about 13 hours by printing with fat 0.65 millimeter wide extrusions instead of the 0.4 millimeter ones. But not only is it fast, it's precise. I put the clearance castle from Maker's Muse on this, and a little over an hour later I had a perfectly functioning model. Nothing was stuck, and nothing was binding. After a few twists and turns of the cylindrical maze, I removed the left side tower and was able to open the castle gate. So then I threw the Autodesk Kickstarter test print on it, and an hour and a half later I had this. These spikes are very fragile and I broke one, but look, almost no stringing. There was a bit of an issue on bridging on the edge of the platform, and the overhangs are a little rough at the 20 degree and 15 degree marks, but all 5 of the clearance pegs popped out easily. I am just so impressed with this printer and what it's able to do, and how quickly it can do it. So, is it all too good to be true? Are there downsides? Well, the current implementation of the printer's firmware requires it to have an internet connection with Wi-Fi, so that you can associate it with your Bambu Lab account. Account? Yeah. Using the Bambu Lab mobile app, you need to create an account on their service. Once that's done, the printer shows up in the app and in the slicer. Having the printer internet connected is necessary so you can monitor the status of the printer, view its camera, and control it both from the app and the slicer. It's also required to send print jobs to it. That means that in the slicer, you need to sign in using the credentials for the account you created in the Bambu Lab app. When printing from the slicer, it uploads the job to your Bambu Lab account and the printer downloads it and prints it. Some people may want to use the printer in a location where they don't have Wi-Fi or an internet connection. And some people may have a Wi-Fi network, but they may not want to have their printer connected to it. Apart from the initial requirement to be on a Wi-Fi network to connect the printer to your account, you can use the printer off the grid, as it were. You can save files from the slicer to a micro SD card, insert the card in the printer, and print them that way, just like the good old days. What other problems could I think of? A complete doomsday scenario would be something going horribly wrong with Bambu Lab and the company shutting down and disappearing. With a cloud-connected device, that could definitely be a problem. As it stands, though, Bambu Lab claims to have spent nearly the past 2 years developing this product, so they've got a significant investment that I'm sure they don't want to abandon. As for customer service, it remains to be seen how support requests will be handled and how hardware failures will be addressed. I'm pretty sure Bambu Lab will handle parts failures by shipping replacement parts that you install yourself, but if you're not super comfortable replacing parts in a printer, that should factor into your decision about getting this printer. So this video has gone kinda long, but there was a lot to cover. The X1-Carbon with the 4-slot AMS unit retails at US $1,449. That's the non-Kickstarter full retail price, under $1,500. And the Kickstarter early bird pledges are at $999. Even though that's toward the higher end of the consumer market, I feel like this machine is going to push the consumer level 3D printing forward by a lot. LiDAR, force sensors, vibration compensation, AI-based first layer analysis, and spaghetti detection. There is so much technology in this thing to make it as configuration-free and hassle-free as possible. The feature set is just incredible for the money. I'm really hoping the Kickstarter works out well for them. I'm planning to back it when it goes live. I like that printer that much. But going into it, I am 100% aware that I'm gambling that $999 on the Kickstarter. If you are uncomfortable risking that amount of money, then please don't risk it. Wait for the campaign to end and pick the printer up at the full retail price. To me, the printer is worth having even at that retail price. Big thanks to the team at Bambu Lab for sending this over so I could show it to you. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. And 4 times faster than normal. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.